Hello everyone, welcome to the course Data Science. In the previous lectures, we had seen the importance of data science and the importance of NumPy and Pandas. Since data science is dealt with two important programming languages, R language and Python. This course is dealt with Python. In Python, NumPy and Pandas are the most important libraries that are useful in understanding data science. So we have seen few operations, few codes in NumPy, and we have also seen in Pandas as well. And this course, this lecture deals with some more operations can be done with the help of Pandas for data science. Okay. So in that, the topic which you're going to see in this lecture is in the index objects, re-index, drop entry, and selecting entries. So first, what is indexing? So for example, if you make a data frame like this is age, this is register number, this is name. Okay, so for this we have to give index, like we can give the name, the index like serial number 1, 2, 3. Okay, so indexing, so this indexing is a fundamental operation for accessing and manipulating data efficiently. So like this is for example 1, 2, 3, and then we can keep this as an index, or we can keep this as an index. So this index is used to access and manipulate the data efficiently. It involves assigning unique identifiers. For this, you can give unique identifiers or labels to data elements, allowing for rapid retrieval. So if you have identifiers that should be unique, if you have unique identifiers or unique labels, means it's easier. So the retrieval is faster and the modification is also faster. So let us see the index objects. Pandas, a powerful Python library for data manipulation, extensively utilizes index objects. So for example, let's take this one. So this is a common default index. And then these are the row index values. These are the column index values like employee ID, skill, age, pay, name. Okay. And this is the column index position. This is the row index position. So indexing is very important to access the data easily, rapidly, and to do the alignment as well. So these are immutable sequences used for indexing and alignment. Let's see the characteristics of index objects. One of the important characteristics is immutability. So once it is created, it cannot be modified. So there is immutability. Alignment means once the index objects are used to align data structures like series and data frames. So let's see the align. And flexibility, Pandas offers various index types, including integer based. So the index type is not only string, it could be integer, or it could be date time, or it could be custom indices. So you can also prefer your own index. So let's take this example. So first, since we are using Pandas, so we have to give some in the simple name. So import Pandas as PD. So this is the data. So for this, the column is name. Under column, we have John, Alice, and Bob. Another column is age. For the 25, 30, 35 is the elements. So for this, if you want to make a data frame, this is the data frame. Okay. So first thing is, before we understand the index objects, first we need to make a data frame. So we have to put data, open the flower bracket and close the flower bracket. And inside, we have to give each column name. So that should be in the string. And then under this, we have to give the names and or the elements to be filled under name. Okay. So in this code, we have framed, or we have created a data frame. So now we have to use the index. Okay. So next one is data range. In that pd dot data range. So the first date should be first 1/1/25, and the periods should be 3. Okay. So I mean 3 periods, and each with the day. So which means 1, 2, 3. So when you give this, so you'll get 3 dates, 1, 2, 3, and so this is the data range, and for that we have given the names and the age. So name is John, Alice, Bob, and the age is also given. So here we have to make a data frame. So usually if you put data frame means you will get a data frame like that. But we have added one more point. The index is equivalent to date underscore range. So your date, already we have created the date. So the date should be the range. So this index 0, 1, 2 is replaced with in the date range. Okay. So this is one kind of indexing, and we can give customer index also. We can give customer index, so custom index or customized index. So ABC, so this is the values. So now I have to use ABC. So instead of this date range, I can use ABC as well. So see this is a default index. So here I have mentioned the index should be data range, so that is why it is replaced with that. And in the next one, I wanted to replace with custom index, that to ABC. So here it's given like yeah, pandas are for various index types, including integer based. So this is integer based, and the next one is date time, and next one is custom indices, for which we have seen the example. So these, let's see one more example. So here we have created data range. The dates should start from 1/1/25 and the period should be 3. We need 3 dates, and the frequency is week. Okay. So the first one is, so in this the it should be with the week. So 5/1/25. The next one is 12 because it's a week. And then here the week starts from Sunday. That's why we have now taken 1/1. Okay. The week starts from Sunday. That's why 5 is the first week, and 12 is the second week, and 19 is the third week, because 3 periods is given, and the duration, I mean the frequency is week. Okay. So in this way we can give the daytime index. So this is also one index. Okay, next, importance of indexing in data science. So already we have seen, if it is indexing means it's easily accessible. So there's a well-indexed data can be accessed quickly. And optimized queries. Indexing supports complex queries and aggregations. And aligning data based on indices ensures accurate calculations and operations. And indexing enables efficient data modification and filtering. Okay, so these are all possible with indexing. Okay. So next one is how to create an index. So we need one pandas library. So this is data which is going to be converted into data frame with the title, name, and with the title, age. So we made name and age, and then here it's clearly specifically mentioned index should be ABC. That is why ABC index is given. So this is one kind of creation of one type of creation of index. And next one is re-indexing, is a process of creating a new data frame or series with a different index. So the re-index method is used for this purpose. So let's see that. So application of re-indexing. So ensuring that data frames have the same indices before performing calculations or merging, and use fill value or interpolation methods to handle missing values, and changing the index order, rearranging the order of rows and columns. So these are the applications of re-indexing. So for if you, when the re-indexing can be applied in changing the index order, filling the missing data, and aligning data frames for operations. We'll see some. So we can, these are the examples for application of re-indexing. So let's take the first frame. So in the first frame, df1 is df1 index or xyz, data is 1, 2, 3, and next data frame is df2, index is y, z, x, the data is 4, 5, 6. Okay, the operation we have to perform is df1 plus df2. So it will add only the, I mean the equal index. So if x, here also x. Okay, so using this we can add. So 1 plus 6, 7, and then 6 and 8. So this is one example using in the indices. Okay, so next one is we have one more data frame, so which is df. Okay, so in that, so the column name is A and another column name is B. So under this column, you have the data as 1, 2, none, 4, none. And then here, none, 5, 6, none, and 8. So this is the data frame. So here we have to fill in the missing data with 0. So that is why in the answer, so here in the third one is nan value, so that is 0 is filled. So here nan value, here nan value, and here also nan value. So this is also one more application of reindexing. filling NaN values, not a number. So this code says we can replace the NaN value with the interpolated value. So here this 4 is the interpolated, and this one also interpolated. So with respect to the previous example. Okay, then we'll see one more example for reindexing. So in this case, this is the first data frame. So we made that. This is the data frame we made, and I want to reindex. So the reindex format is CAB. So CAB is reindexed. Accordingly, the names and age will be aligned. So for that, you have to give reindex, and what is the new index actually. So reindex of this already, I mean, in which order you have to arrange it. So that's that you can give. Okay, next one is reorder the columns. Okay, so here the reorder column is first age and name. So in the previous case, first name and then age. Okay, so I can reorder the columns as well. So the in which order it has to be appeared, that has to be give like this. So age and name. So automatically it is reordered. So reindexing. So one more example for reindex. So here this is the normal one, and the reindexing is ABDE. So ABDE is there, and for AB data we don't have data for D and E, so that has to be filled with NaN. So this is one example for reindexing. Okay, and the next one is drop entry. If there is an outlier, or if there is a data loss, or if there is any missing value, we can use this technique, drop entry. So dropping entries in data science refers to removing specific rows or columns from a data set. This is a common operation in data cleaning and pre-processing to handle missing values, outliers, and irrelevant information. Considerations before drop entry. Missing values. If you have any missing value, consider imputation or other techniques before dropping. So you have to fill with some value before dropping. And for outliers, carefully analyze the outlier before you remove them, because that might give useful information. So that's why you have to be very careful to remove the outlier. And data loss, dropping entries can lead to data loss. So proceed with caution. So before you drop the entry, you have to be very cautious that the data should not be lost. So we'll see one example for drop entry. So here, this is the data frame. The data frame name is, I mean, the columns are name and age, and the data is filled. Okay. And in this DF drop, so I have to drop. So which one I need to drop? Age. So I have to drop the age, but that age can be accessed through this way or this way. Okay. But I want to, I mean, here I'm going to use columns, okay? So which means that a particular age column will be removed. So it has to be, I mean, the removal should be based on the axis, either it is in a column form or rows form, okay? So this is one example for drop entry, and you can select the entry. So Pandas provide several methods to select specific rows, columns, or subsets. Okay, so how? So first you have to select by label, and next one is select by position and select by condition. So we'll see one example. So first one is selecting by label. So this is one normal data frame. In this, we have three columns, name, age. So the index is not mentioned properly. So that is why automatically default index 0, 1, 2, and then the names, age, and city. So this is a normal data frame. So in this data frame, I'm going to specifically choose one column, age. Okay. So here this the semicolon says I have to take all the rows. I have to take all the rows, and which column I take? Age column. So among these three columns, age is selected, and for that age I need to take all the rows. That is why this column. Okay. So suppose if I want to select only this means, so I have to put 0 to 2. So 0 will be selected, 1 will be selected, the last one is not selected. Okay. So if you just it is an empty, then it shows all the rows should be taken. So in that way we can specifically choose a column. So that is selecting by label. Next one is selecting by position. So again, you need to form one data frame. This is the data frame. So it has three columns. It has the index. Okay. So next I have to select by position. So these are the positions. So this is first row 0, row 1, and row 2. Okay. So if I want to access the row second, so I have to give df dot I location, I mean I loc of 1. So which means this one will be selected. This is 1. Okay. So the data is Bob 30 and Los Angeles will be selected. Okay. So in that way we can select the particular element by position. What is the position? Z1 is the position. 1 is the position. Once you give the position, the particular elements will be selected. Then you have to select by condition. So here we have given the condition like if df of CD, this is a data frame. Under this, you're going to consider we cannot just put age because the age is under df. So df of open the square bracket age is greater than 30. So under this, which one is greater than 30? Only 35. So that will be selected. Charlie 30, 35 and Chicago. So this is selecting a particular row or column by condition. Okay, so far we have seen reindexing, DOP entry, and how to select. Okay, so the next important thing is data alignment and rank. And so in this code, we are going to see data alignment. Okay, so data alignment, for that we have to use align function used to align two data objects. It can be applicable for both the series as well as data frame. It will return a new object when once the labels are compared and aligned. So let's take two examples. So this is one panda series, this is one panda series. So we have to align this. Okay, aligned s1 comma s2, and then this is the function s1 dot align s2. Okay, so you have to print aligned s1. So once it is aligned, it will take the common index. So the common indexes are A, B, C, D. I mean, once you align, you have to consider the index of the other PD dot series as well. So in the first thing, S1 you have ABC, but in the second you have BCD. So if you combine, you will have one common thing like ABCD. Similarly, for S2 as well, ABCD. But see the data in the first case, I mean, A value is there, 10 is there, B is 20, and C is 30, but D is not there. So D is not given. So here D is not given for the first case. And then for S2, BCD is there, A is not given, so that is none. Okay. And see the thing is here we have to align, I mean you have to add aligned S1 dot add of aligned S2. So as aligned S2 should be added to aligned S1. And then if you have any NaN value, that has to be filled with 0. Okay. So we have to add. So here you have A is 10, but this is NaN. Okay. So this has to be filled with 0. 10 plus 0 is 10. Okay. Next one is B is 20. Here this B is 5. So 25. And next one is 30, and then this C is 15, so 45. And for D it is none, so replace with 0. 0 plus 25, 25. Okay, so this is called as data alignment. Okay, then one more example for data alignment. So here, so first we have to frame the data frame. So here, PD dot data frame, open the parenthesis. Under that you have to give, I mean, three labels A, B, C. Under that the data. So A, B, C. This is the normal index. And similarly for the next data frame, A, B, D. The column is A, B, D, and the data is given. Okay. So next we have to align. So here is the data. So how do we align? So df1 dot align df2, and you have to fill the value. If you have any unknown data, that has to be filled with np dot nan. Okay. So once it is aligned, see here you have only ABC, but here ABD. Okay. So if you consider in total, you'll have 4 columns. So ABCD. But for the first df1, your data will not be there. So for that you have to fill with nan. Okay. For the second case, the last row will not have values, and then some C also will not have value. For that you have to fill the nan value. Okay. So then next you have to print, you have to add and print, add the corresponding numbers, print and fill the NaN value with 0. So A and this 10. So here this 1 and 10 is added. So that is why here it is 11. And then here B is 4 and this B is 12, so 16 is added. And if there is any nan value, then that has to be filled with 0. Okay, but here both are nan, so that is why nan value is filled. So this is also one data alignment. And next one is rank of the matrix. So ranking is assigning positions. Ranking assigning positions to the data elements based on their values. Rank is returned based on position after sorting. So for rank, first thing is you have to sort. Sorting is important. Once it is sorted, then position is given. So used when analyzing data with repetitive values or when you need to identify the top or bottom entries. For that, we have to use rank. So the syntax is rank is a function, and inside you have to mention whether it is, are you going to apply axis, zero axis or first axis or columns, and what method. Gender default method is average, otherwise you have to mention what type of method is that. uh, but the position, so you have to give the rank based on the position, so that has to be average. Numerical value, and I mean, not a nan number, you have to keep. Okay, you should not reject it. And then ascending always, because it's sorting ascending order, so it should be true. And percentile is false. That is, it returned rank as a percentage or a integer rank. Okay, so it always the rank as a percentage, but not as a integer rank. Okay, so let's see one example. So here also this is the syntax is given. Syntax is given and the syntax explanation, which I've seen already. So we'll see one example. So here we are going to use both NumPy and Pandas. So that's why import NumPy Pandas, and we are going to convert, or we are going to create a data frame. For that, animal is the name of the column. Another one is legs. Okay. So the data is given. So you have to frame a data frame. Okay, next. So we'll see the rank. Okay, so first see the code. So here animal, and the animal names are there. The same thing is repeated. Okay, so this is one example for ranking. So here I'm going to use the rank function on a number of legs. Okay, and already we have discussed in the syntax, it should be an average. So in this, because you have to consider only the number of legs. So the number of legs is, first you have to sort it. So when you sort, 2 comes first, and then 4 and 8. So 2, 4, 4 and 8. Okay, so 2, there is no doubt a position is 1. And for 4, 1 is to second position, third position, and this fourth position, this fifth position. But while you give rank, if the values are repeated, then you have to take the average. So 2 plus 3, 5, 5 by 2, 2.5. So the position, the rank is 2.5, 2.5. And this is normal, fourth rank and nan rank. So this is called as ranking. Okay. In the next case, you have to rank, but the method used is maximum. Again, first you have to sort it. This is the first, it comes first, 4 comes second, this 4 comes third, this is 4, this is 5. First you have to order it, and you have to find out the position first. So 1, since this is sorted 1, this is 2 and 3 and 4, 5. So since in this, the method is maximum method, among 2 and 3, the maximum number is 3. So this should also be replaced by 3. Okay. That is why this is replaced by 3. That is kangaroo. Kangaroo number of legs is 2, but the ranking is 3 because the maximum number is 3. So this is 3. And the others are same. Okay. So this is called as ranking using maximum method. And next one is, again, you are applying the rank on the number of legs, but nan option should be at the bottom. Let's see. So again, first you need to sort it out. So number of legs, once you sort, so it becomes 2, 4, 4 and 8. Give the position. So 1, 2, 3, 4, 5. And ranking also 1, 2.5, 2.5, 4 and 5. I have already seen it. Okay. But the if you have any nan position, that has to be given bottom, which means the highest. So in this first rank 2.5, 2.54, and this is given as fifth rank. So that's why fifth rank. So this is also one more ranking. Next one is you have to apply rank using percentile value. Again, first you have to sort it out and give the position and give the rank. Okay, so how to calculate the mean percentile. So this rank divided by the number of data. So here 4 data, that's why. And then here 2.5 divided by 4, 2.5 divided by 4, 4 divided by 4, and then 5 is a NaN number. So this is the formula is present rank divided by highest rank. So in this, you have to take the present rank is 1, the highest rank is 4. But leave the NaN database, this is we filled it, but it's not original. So that's why the maximum rank is, highest rank is 4, minimum rank is, the present rank is accordingly which element you are dealing with. Okay, so this is one rank which is based on percentile. Okay, so what is the use of sorting? So sort by values along the axis. Either you have to sort row wise or column wise. Sort a pandas data frame by the values of one or more columns. Use ascending order, and the code is dot sort underscore index, and organize the missing data while sorting values. So if the missing data will be organized, and you have to use in place because it will be replaced. Okay, so this is the syntax. The syntax is data frame dot rank of axis. You have to mention the, because already we have seen method is average, and no default, and ascending order is true, and percentile is false. Okay, so one example we'll see. Okay, so here is the data frame. So this is the data is given for each, and in the second line you have given the columns. The columns are country, year, population, and continent. So we made a data frame after giving the data. Okay, so in the next thing, first we are going to sort it using country. So here's the country. So sorry, here, country. Okay, so you have to sort by country. So choose the country. So here you have to arrange it in the order. So in the previous case, it is not in the order. So you have to sort it out first. Afghanistan, Australia. So this is arranged in the order. Accordingly, the year, population, continent will be aligned. Okay. So here we sort the data frame using population column. So this is the command function df dot sort underscore values. Then how do you sort? By using population, but it should not be ascending, it should be a descending order. Okay, so you can see that. So the highest population will come first, then accordingly it will be aligned. So this is called as sorting function. The next one is we are applying this sort df dot sort. This is the command df dot sort underscore values. So how do you sort? By using population, but your NaN position comes first. Okay, so your NaN position comes first, then next or it is called as, I can say, ascending order, but since NaN comes first, NaN is always a zero value, so it means ascending order. So accordingly we can sort it. Okay, and one more example. So here this is the data frame. So the data frame columns are country, year, population, and continent. So here you have to sort it. df dot sort underscore values by country and continent. You have to consider country as well as continent. Okay. So here Afghanistan, okay, Asia also first one. And then you have Australia here, and then for that the continent is Oceania, and Brazil, America, China, Asia. See here. So here continent is Asia. You have two in Asia continent, but different, Afghanistan and China. Okay. So make sure that it is both should be aligned. I mean both should be sorted. So compared to Afghanistan and China, Afghanistan should come first. That's why Asia, and then Asia is repeated here as well. Similarly for India also. Okay, so India belongs to Asia and as well as Oceania. So accordingly it is, so you have to sort both country and continent. Okay, so we have seen alignment, data alignment, that is ranking, sorting values. For ranking, first you have to sort it first, and give the position. If the positions are repeated, and you have to take the average of it, and ranking could be either average or maximum method or percentile. So likewise you can give the ranking. Okay, so the next topic is statistics. So we are all familiar with statistics. The basic statistics are mean, median, mode, standard deviation, like that. Okay, so here summary statistics offer a quick and insightful overview of the main characteristics of a data set. So here we have to use describe. If you use describe function, it will do all the statistic calculations. So let's see that. So here in this lecture or in this topic, we are going to see mean, median, mode, and also correlation method. Okay. So let's take first example. In the first example, there are two columns, age column and salary column. So first you have to frame a data frame. Okay, so this is the data frame. So the data frame is not given, but we can print it. So the data frame is you have age and then salary. Then age is 25, 30, 35, 40, 45. Accordingly, you have to give the salary. So this is the data frame. And the index is not mentioned properly. So that's what default index like 0, 1, 2 like that. Okay. So now we have to print the statistics. So for that you have to give df dot describe. Okay, so df dot describe means it will give first one is count, how many count you have. So how many count you have? You have 5. So here count is 5. Okay, and how much is the mean? So mean is 35. Okay, and standard deviation 7.9. Accordingly the salary will also be okay. So for 35, what is the salary? And for 5 just it's the same only, 5. And for minimum, so which one is the minimum? 25 is the minimum. So 25 accordingly that particular salary. And then 25 percentage. So 25 percentage means, so in this the 25 percentage is 25, I mean 30th value. So how to do that? So for that, you have to take the total number of values are n. So n minus 1, okay, into 25, because I'm going to find 25 percentage, divided by percentage is 100 plus 1. So this is n minus 1 is 4. 4 to 25, 100 by 100, 1. 1 plus 1, 2. So you have to take the second position. So the second position is, because 1 plus 1 is 2. So this is 1, this is 2. So for 25 percentage, 30 is given. Okay. And for 50 percentage, so it is 4 into 50 divided by 100 plus 1, which is equivalent to, so this is 4 into 50 means 2. Okay. So 2 plus 1, which is equivalent to 3. 3 means 1, 2, 3. So 35. So 50% is 35. Similarly, 75% is 40. Maximum is 45. So these are the various statistics. Okay, then one more code is, so here two column A, B. So A is 1, 2, 3, 4, 5. And then B is 10, 20, 15, 25, and 30. So first you have to frame a data frame. So we made, so automatically the index will be 3, 4 like that. First you have to print mean value. So what is mean values? Df dot mean. So you have to find the mean for all. So the mean is 3 plus 3, 6, 6, 4 plus 4, 10 plus 5, 15. So 15 by 5 entries. So the mean is 3. Similarly, 30, 35, 45, 50, 70, 100. So 100 by 5, which is 20. So this is mean values. Next one is median. So since you have odd number of entries, so you can easily fix the median value. So one is 30, so 3. Another median is 20. Okay. So the another median value is 20. So you can find it out. Okay. So the next one is mode value. So mode value is the frequent occurrence. So we have to take the first value only, because this mode value is df dot mode. So generally mode returns the complete column. Okay, but I don't want complete column. I want to have only the particular location. So in that particular location, the first 0 means first element. First element is 1. The second column, first element is 10. So that's why 110. So remember, dot mode is it will return the complete column. But since I don't want the complete column, I want to have a particular element. So in order to have the particular element, you need to use I location. Okay. And next one is correlation. So here the data is A and B, 1, 2, 3, 4, 5, and then here 10, 20, 15, 25 and 30. Okay, so here I need to find out the relationship between these two. Okay, for that purpose I have to use df dot correlation. Once you apply that, it has many methods like Spearman method. So the method is applied and then the correlation matrix is found. So for correlation matrix, this is always 1 because the relationship between A is all, here also A, here also A, this is 1 only because both are same. And then this also B, this also B, so this is 1. And then here it says A and B are having positive strong correlation because 1 is the best correlation. If any number is approaching, then we can say positive strong correlation, which means if A increases, B increases. So almost if A increases, B is also increasing. So this is called as correlation. And one more correlation we'll see. So here study hours and exam score and TV hours and sleep hours are given. So I need to find out the correlation between them. For that purpose, I have to apply correlation. Okay, so here after correlation, you will see that. So the diagonal elements are 1 because it is self element. Okay, now study hours and this one. So 0.99 means it is strongly correlated, strong correlation. So when you study, when you spend more hours, you will have more exam score. Okay, whereas this case negative correlation, that is when you study more, I mean your TV hours will be lesser. Okay, and the sleep hours. So when you decrease the sleeping hours or when you decrease the TV hours, study hours will be more. So this is negatively correlated. Similarly here, the second 0.995. So if your exam score is increased, means study hours are increased, and if your TV hours are reduced, exam score will be increased. Similarly, if your sleeping hours decrease, exam score increase. So this is one type of correlation. Then here, see, for TV hours, sleep hours, it's all negative correlation. Only for see here, if you decrease, I mean, if your TV hours is decreased, sleep hours decrease means, so this is a positive correlation. It is useful for the highest score. Okay, so this is called as summary statistics. So in the statistics, we have seen basically mean and median, mode, and count, and the 25% or a particular percentile we can see, and also correlation. Correlation means suppose we have a few columns like A, B, C, D, E. These are the 5 columns. I want to know the relationship between A and B, B and C, and C, D, E, or A to B, or A to C, A to D, A to E. So I have to find out the correlations between these these 5 columns. So for that, I have to use df dot correlation. So if the values are closer to 1, if the values are approaching plus 1 means this is positive correlation. That is, if one variable increases, other variable will also be increasing. Or if it is away from plus 1 means it is negative correlation. That is, if one is increasing, the other variable should be decreasing. So in this way, we can find out the correlation between different columns. Okay, so with this I'm finishing this pandas. So we have done numpy and pandas in the first unit. So we have seen many operations, but in the second and third unit we'll see each and every code for a particular function in detail. Okay, so that's all for today. Thanks for watching.